4. Working backwards. It is basically the exact same thing we did in reverse. Okay? It's going to be the exact same stuff in reverse. And instead of asking you guys what the sine or the cosine of pi over 4 is, I'm going to say what angle has a cosine of pi over 4. Oh, what angle has a cosine of root 2 over 2? Well, you have to figure out where root 2 over 2 occurs. It occurs at 45-degree angle, or pi over 4. You're working backwards. You have seen this. This is inverse trig functions. So what's going to happen here is that we have to make sure that we understand where things are positive and negative and what quadrants we're basing our work off of. And that's kind of the trickiest part of all of it. Evaluating trig functions. Your sine functions, when you are trying to find an inverse sine, your inverse sine functions are always going to be within the thetas between pi over 2 and negative pi over 2. Okay? Because we want positive values. Our angles are going to be positive. Okay? Yes, I know we can have a negative angle and all that kind of stuff, but the A value, we want it to be positive here. So what I want to do today is kind of list out what quadrants we're looking for. There are 3 rules for sine, cosine, and tangent. For sine, your parameters for the sine function, your inverse sine, you're always looking within the quadrant 1 and quadrant 4. And this will make a little bit more sense when I give you guys some examples here. So sine is always between quadrant 1 and quadrant 4. Remember, they list that out between no smaller than -1, for A, and then the 1. So that means your values, your angle values, are going to be between negative pi over 2 and pi over 2. Okay. Remember, that's the whole idea again about the reference angle. Instead of saying our angle is going to be pi over 4, we'd say it'd be negative pi over 4. That's what we're saying. And it goes the same thing with the negative 90 degrees versus 90 degrees. So what we're looking at here is that sine functions are going to be between first and fourth quadrant. Cosine functions are going to be between first and second quadrant. Same ideas. Cosines are going to be between the first and second quadrants. And one thing I want you to remember, excuse me, I'll wait to show you an example of how this works. So sine, I'll write this up here while you guys are writing that out. Sines, inverse. You guys all remember the inverse button when you had that -1? That means inverse function. That's in quadrants 1 and 4. Cosine is in quadrants 1 and 2. And then the tangent function, if I'm not mistaken, was also 1 and 4, but it cannot equal 0. Okay. Why can we not have this equal to pi over 2 or 90 degrees? Why can't I have that equal to pi over 2 or 90 degrees for tangent? What's the ordered pair at 90 degrees? 0, 1. Tangent sine divided by cosine, so I'd be divided by 0. That's why it doesn't work. It's what we call it when we graph tangent next chapter, you get vertical asymptotes. Sine Sine and tangent are both 1 and 4. Cosine is 1 and 2. There's okay. And we're getting to why this works here in a second. So what's going to happen when you have these values, you're going to look at something like this. I'm going to ask you to figure out what angle has the sine that equals root 3 over 2. That's what this says. This says what angle has the sine that equals the square root of 3 divided by 2. So when you're thinking about what that means, since it is a sine value, that means you have to look at the quadrants 1 and 3, and you want to figure out what angle has a sine value that is root 3 over 2. So, sine values are the y-coordinates. Do you agree? Okay. Thank you, Happy Dinosaur. Since the sine values are root 3 over 2, that's the y-coordinate. Remember, this is why I gave you guys that trick. 3, 2, 1, 1, 2, 3 for your ordered pairs. Which one is the y value that has a root 3 in it? 60 degrees. 60 degrees has the y value of root 3 over 2. So that means the sine inverse root 3 over 2 is going to equal 60 degrees, or in terms of radians, pi over 3. That's what that says. Okay? It's about knowing which ordered pair are you looking at? Are you looking at the x-coordinate, the y-coordinate, and where is it equal to that value? Since it was a positive root 3 over 2, I'm first quadrant, 60 degrees. If it was a negative root 3 over 2, I'd be in the fourth quadrant, and I would be at, well, down here, I subtract out the pi over 3 for the angle, so it would be what? 5, is it 5 pi over 3? Do that, okay? So that's what this looks like. Cosine of 2. Cosine of 2. Well, if you look at your cosine values in the first, remember, first quadrant, cosine are, you're looking at quadrant 1 and quadrant 2. In quadrant 1, remember, 3, 2, 1, 1, 2, 3. As you go across here, these are all, root 3 over 2, root 2 over 2, and 1/2. Do any of those values equal 2? Yeah, I'm just writing it into the 3, 2, 1, just so you guys remember. These are all like root 3s, root 2s. Is that okay by doing that? You guys know what that means if I write 3, 2, 1, 1, 2, 3? Is that, do you guys understand which ones are roots and which ones are just 1/2? Okay. Did you get that shortcut?
No, I see it.
Okay, remember, the easiest thing to remember when you're looking at your unit circle, the ordered pairs go root 3 over 2, root 2 over 2, and 1/2 for the x-coordinates. All I'm saying is that if you remember 3, 2, 1, those are the numerators going up. Then the y values would be 1, 2, and 3. As long as you remember that everything has a denominator of 2, and the 2's and the 3's are radicals, you're going to be fine. All right? It's just a shortcut way to remember it. Because then you'll know that this mirrors over here, this mirrors here, and this mirrors here to the next quadrants.
So like the y's go like are the same on the other side.
Yeah. The y values are going to be the same because they're horizontal.
So then like the x is like when you go down the x values are going to be the same.
As you're coming down this way, it's 1. Your x values would be 1, 2, 3. Your y values would be 3, 2, 1. Okay? And then just mirror it going all the way around. That was the whole idea yesterday when I did those rectangular boxes. So everything showed up the same way, going all the way around. Okay? So now if you think about Do you get just cosine equal to 2 anywhere? No, we don't. This is undefined. Okay? It would just be undefined. If it asked you what the inverse secant was, and it said what angle has an inverse secant of 2, that would work. Because inverse secant would be flipped over, it'd be what has a cosine of 1/2. Well, pi over 3. Okay? So you have to remember when they're giving you inverse functions, you have to flip your ordered pairs and go through. Tangent of -1. Tangent -1. Well, remember, tangent, whenever we have a tangent that's equal to a 1 or a -1, that means the ordered pairs are the same. Remember that? The only set of ordered pairs that we have that are the same are root 2 over 2's. And it's negative, which means it's down here. So the ordered pair for the fourth quadrant tangent equal to -1, well, it would be root 2 over 2 and the negative root 2 over 2 with an angle of, well, it'd be negative pi over, you can write it as negative pi over 4. Because I don't believe it wants you to go, it'd be negative pi over 4 or negative 90 degrees, but if you want to put it positive, that would be 5 pi over 4. No. 7, thank you. Duh. And then this isn't 90, it's 45. Or 315. Okay? Because that's your fourth quadrant. What this is giving you, if you think about it, like you said, you got to go down the negative pi over 4. The reference angle is this. This is the reference angle to the original on the unit circle.
Which one would you want to put?
I always write them as positive. Double check what the book does. Sorry. That wasn't this time. I just really don't like it. Oh, did I say that out loud? I'm kidding, Dave. I was joking. No, I'm not recording that. No, well, you go to give me the high five, but a little too late there.
That was like a stretch.
Yeah, you know what? The rules, remember, okay, the rules, they want you to go with the negative. Because here they're talking about between negative pi over 2 to theta to pi over 2. All right, so you want to keep them within that. Same thing here. This is between pi over 2 and, all right. So we'll just keep it at the negative value. The second part of this is the easier stuff. How much we have? 4 minutes? All right. I'll cut this up. How's your shoulder feeling? I forgot to ask you yesterday. When you step on your foot, it'll alleviate remembering about your shoulder. All right, let's see. Now, the problems that are on here, the first 8 are similar to the examples I just did. The other ones are right triangle trig stuff where you're given a right angle, theta, 2 and 4. Find theta. Think about what you did in geometry. This angle is 2 over 4. Opposite and hypotenuse. That means the tangent of theta is 2 over 4. Using a calculator. Do you remember the buttons you have to press on the calculator to find theta?
No.
Theta will equal second tangent 1/2. Tangent inverse 1/2 in your calculator. Do 2 decimal places on a lot of those. Those are the easy ones. And then the last group is the same thing. It's all calculator based. Just give me degree measures for right now. We will try and do radians versions of that tomorrow. Okay? Yes, ma'am.